Okay, kids, so I'm going to ask for you to be very quiet because that's what it involves, making these videos for your YouTube channel, especially because product rule is an important element when I start to teach you the chain rule. It's extremely important to incorporate the product rule and the chain rule. So I want a video that you can refer to that has detailed solutions. Now, I am aware that you worked on some of this in your hallway math, but it's a good idea that now you can cross-check what you did with your groups and check with the steps that I am laying out here. Okay, so we're going to start off with taking the derivative on the side. Okay, we're going to take the derivative on the side. I'm not going to be able to get through every single question, but I'm going to try my best. So we're going to start off with taking the derivative of f prime of x. Let me just fix up a little bit. Okay, so as I mentioned, product rule is an important element of chain rule. We have to understand the product rule in order to apply the chain rule later on, and that will be my lessons starting next week. So I've labeled the first binomial f of x and the second binomial g of x. That's to represent a product. Now, I could have chosen h of x, t of x, different letters, but I'm trying to stay consistent with the formula that I taught you right from the beginning, so there's no confusion. So the derivative of my first function, f prime of x, right? That is pretty much, you should be able to look at that function and figure it out. I'm going to start by applying the power rule. So we would bring the x to the power of 1 in front as the coefficient of this term. Multiply that by 5, subtract 1 from my x to the power of 1, and that's how I get that f prime of x is equal to 5. I will be using that in the product rule, purposely starting off very simple because we are going to get quite complicated as we move through our examples in this course. Now, if I'm looking at g prime of x, that's going to be equal to, I'm doing the same thing, 1 times 8 x to the power of 1 minus 1. So my derivatives are going to be simple to substitute because I'm dealing with constant terms. And we all know x to the power of 1 minus 1 would be x to the power of 0. This is my work on the side. It doesn't necessarily have anything to do with now the direct application. What I will need to see on your test is if we're starting with f of x, remember, if we're starting with y, I would represent the derivative as dy over dx, and I will be showing you proper notation as we move through these. But I'm going to start with f prime of x because the original equation is f of x. F prime of x is equal to, and now we're going to apply the product rule. I'm going to, in a different lesson, do the same thing with the quotient rule, but for today, we're just going to focus on the product rule. So I'm going to take the derivative of the first function, not writing the first function, I'm taking the derivative of the first function, and I'm going to multiply that by the original second function. Now remember, unlike quotient rule, product rule is not a difference. Product rule is a sum. So I'm going to put the addition sign here in different colors. Now I'm going to take the derivative of the second function, which is 8, and multiply it by the original first function. Now, it's very important on your test that you don't just write out the product rule and go directly to the answer. You now have to actually apply the distributive property. You have to apply the distributive property. So what does that look like? 40x, 5 times negative 6 is negative 30, plus 40x plus 16. So that means that, and you know, it doesn't hurt to write f prime of x each time. So you don't just have floating equal signs and you know exactly what you're solving for.
So because the function is defined as the f of x, like on a test, should we change the first function to maybe?
Now, I just wrote f of x and g of x to, you wouldn't write that on a test underneath. That is just to remind you of the original formula I gave you. I should only see f prime of x. I shouldn't see any of this notation. This is for teaching purposes, right? Okay.
On the side.
Can I just finish solving this for a second? So 40x plus 40x is 80x, and negative 30 plus 16 is negative 14. Now, on the side, this note that I am putting here is for teaching purposes. I do not need to see you write this on the test. However, if you're taking a screenshot of your solution, most probably you're going to take a screenshot of this as well, just because, but I don't need to see this side notes for marks. What I do need to see is the distributive property, the collecting like terms, that sort of thing. This is just to organize your strategy, organize your thoughts. Okay, so that is the first product rule question. Now I'm strategically picked a couple of questions from hallway math to do. The next question I'm going to tackle involves a negative number, and we're going to increase the difficulty from there. So I have negative t plus 4. I'm going to hide these meeting controls. There we go. So just like before, this is my f of x, first function. Second function is my g of x. Now this time, I'm not going to show the calculations of the derivatives on the side. I'm just going to apply the product rule like I would on a test. So left-hand side, I no longer have the original function. I have the derivative function. Remember, the derivative function helps us find the slope of the tangent line when we substitute x values into it after. So I'm going to take the derivative of my first function. So I'm using blue. Negative 1 would be the derivative of my first function. I'm multiplying that by my original g of x, 2t plus 1. Oops. Try that again, 2t plus 1. Changing colors to show you that this is a sum. Product rule is always a sum. And now I'm going to take the derivative of the second function, which would be positive 2. And I'm multiplying that by my original first function, negative 2t plus 4. H prime of t, again, because I'm really trying to emphasize proper notation. For the limits test, there was many examples where students were losing their notation and starting to write and not explaining mathematically. So I want to reinforce the importance of explaining everything you're doing mathematically. So when I apply the distributive property, correct me if you got something different. but this is what I am calculating. And now when I collect like terms, I get an equation that looks like this, negative 4t plus 7. This makes sense because if I were to actually FOIL the product rule, this would be a quadratic function, and the derivative of a quadratic function is always a linear function. Now, what I do not want to see on the test is you foiling this and applying the power rule. I don't want to see this. I'm testing you to for you to demonstrate that you know how to apply the product rule. So when you see a product, you apply the product rule, not the power rule. Okay, I want to be very clear about that. This is our next function, p of x. Now, again, in blue, I'm going to represent the first function. In purple, the second function. Bear with me here, the difficulty is going to change momentarily. P of x, so this is p prime of x, is equal to, now I'm going to take the derivative of the first function, negative 2, times the original second function, x minus 9, plus, because this is a sum, the derivative of the second function, positive 1, times the original second function, that is going to give me p prime of x is equal to negative 2x plus 18 minus 2. Oh, I switched variables here. This should have been an x, not a t. So negative 2x plus 3. So p prime of x, again, is a linear function, negative 4x plus 21. Okay, so I'm going to leave quadratic questions behind right now. Quadratic are the easiest type of derivatives, in my opinion, to solve. And now we're going to move into something a little bit more difficult. So in your hallway math, you might have noticed that we're moving to cubic functions. And I want to move to this example, which has a higher degree. Now, when I post the lesson notes, I will try to post the solutions for the other questions as well. Not with detailed steps, but just the solutions, so you can check your answers. And I'll do that with the quotient rule when we get to that point. So h prime of t. I want to be very careful because now I'm dealing with powers of 2. And if I actually multiply power of 2, I know that gives me t to the power of 4. So I'm expecting my derivative to be 1 less than that, which would be a cubic function. You always want to kind of remind yourself of that before you start, so you know what your end game is. So I'm going to take my derivative of the first function, quite simple, 2t. I'm going to multiply that by the original second function, 3t squared minus 7. And that will require the distributive property. Separate that by an addition sign, and don't confuse that when you do the quotient rule. You always want to think product rule is a sum, quotient rule is a difference. So I'm going to take now the derivative of the first function, which should give me positive 6t. And I'm multiplying that by the original, so that's a derivative of the second function times the original first function. Okay. Again, distributive property is very important here. H prime of t. Notation matters, folks. When I do my distributive property, I'm going to get 6t cubed minus 14t.
Sorry for the interruption, everybody. John, I'm asking you to kindly go back into the attendance app and redo your attendance to reflect absence for period 1. We were having a glitch and it seems to be resolved. So if you can do so, thank you.
Okay, so I have a cubic function when I apply my distributive property. Notice that I do need to collect like terms. The 6t cubed needs to be grouped with this positive 6t cubed. This negative 14t has to be grouped with the positive 18t. That's how you get your final answer. This is how you get full marks. You have to show me those steps before you collect like terms. I can't reinforce that enough. Okay, so now we're going to get into some difficult problems, and this is the main reason I'm taping today's seminar, because your homework doesn't just always require 2 binomials. Sometimes you have 3 binomials, you have multiple products. So I want to teach you some strategies to help you solve these type of questions. Okay. Before we move on to that, though, let's do one more, because this is a good example. Determine f prime of negative 2. Not the limit of negative 2 or all these weird notations I was seeing on the test. That is telling me what is the value of the function when x is equal to negative 2. Everyone by now should have practiced that extensively in MCR and know what that notation means. But before I can find f prime of negative 2, I obviously have to figure out f prime, the derivative function. So I'm going to start with that. F prime of x is going to be equal to my derivative of my first function, which is 2x minus 2. So here we have a binomial. This is the first time we've had the binomial for the derivative, times my original second function, 3x plus 1. So right away, I know this is going to be more complicated, because the first half of product rule is going to require some FOIL. Then I'm going to add my derivative of my second function, which is a constant number, multiplied by my original first function. Okay, so I'm going to have to apply FOIL over here. And I'm going to have to apply the distributive property over here. So when I do that, f prime of x is going to be equal to 6x squared minus 4x minus 2. I'm going to switch colors now to represent the distributive property part, plus 3x squared minus 6x. Got to show the FOIL as well as the distributive property. Now, when I collect like terms, I can get a final formula for the derivative, which is 9x squared minus 10x minus 2. This is a general formula for the derivative. I cannot plug in an x value of negative 2. It's not positive 2, negative 2, until I find that formula. Now I'm going to create a line here and move on to the second part of what they're asking me. They're asking me to figure out f prime of negative 2. So that means wherever I see x in the equation, I'm substituting negative 2. So I have 9 times negative 2 squared minus 10 times -2 minus 2. So that tells me f prime of -2 is equal to 54. That also means when x is equal to -2, the slope of the tangent line is equal to 54. It's possible to have a big slope like that. But remember, once you have a specific x value, the derivative now gives you the slope of the tangent line. That's very important for your word problem. You might not have got this far with your hallway math, but I do want to put in some answers here. So I'm going to put try on your own. But your answer for this one, and you can always see me if you do not get this answer. Kids, I'm just going to remind you I am recording, so please watch the, sorry? Oh, okay. -2 is equal to 60. Okay, so now let's move on to a long question. I don't know if you got this far in your hallway math, but the question read, determine an equation for the tangent to each curve at the indicated value. So they're not asking for the slope of the tangent line only, they're asking for the equation for the tangent. So I'm going to actually equation for the tangent to each curve. So that means we have to buckle up and really remember our steps. So I'm going to label each step. Step 1, we're going to solve for the common point that we are going to use for the equation. That is the point that intersects the curve and the tangent line. So we're going to start off with that. For the point, I'm going to use the original function, not the derivative, just the original function. And because they're asking me at x is equal to -4, that means I'm solving for the original function when x is equal to, let me be very careful with that, -4, not +4, but -4. So here I don't have to be so exact. I'm just substituting -4 squared minus 3 times -4 squared plus 1. Now, because these are all numerical values, you can just tell me the value. This is just like plugging into your calculator. So that means that my common point here, the points that I'm going to be using later on for the equation will be when x is equal to -4, y is equal to -221. It's okay if you have a large value for your point. That's totally fine. Now I'm going to move on to step 2. So step 2 is going to be to solve for the slope. Bless you. So solving for the slope means I'm going to require f prime of x. I'm going to require f prime of x. So you got this far in hallway math. Let's check what your answer is. F prime, yes.
Sorry, I think your point might be wrong.
Sorry?
I think the point might be wrong.
-4,
-221. That's what I have here.
Because -4 squared is positive. Positive?
Positive 16, but then you have to multiply the 2. Oh, positive 16 minus 3.
It's 13 times, which is a positive.
Oh, yes, it is positive. Thank you very much for that. Positive 221. Great. That does work out later on. Okay, so we have positive 221. Okay, now for the slope calculations, if the smartboard will let me. So I'm going to start with the derivative of the first function, which is 2x, times my second function, x squared plus 1, plus the derivative of the second function, which is also 2x. But now we're going to multiply it by the original first function, x, let's see, x squared minus 3. Just because this is a longer question, I do not want to sacrifice what I have learned about applying the distributive property. So I have 2x cubed plus 2x plus 2x cubed minus 6x. Oh, what happened there? 2x, try writing that again. 2x cubed plus 2x plus 2x cubed minus 6x. So if my derivative is f prime of x, which is equal to 4x cubed minus 4x, to find the slope, I'm going to substitute -4 into the equation wherever I see an x. We're substituting -4. So that's going to turn into 4 times -4 cubed, -4 minus -4. And again, we have a numerical value here. So this time I know negative, negative, my answer is going to be a negative. Okay, last step, we're hanging in there. The last step is to solve for the equation of the tangent line. So I'm going to do two things. I'm going to extend the page here, and I'm going to draw a line. Okay, so what formula, can someone tell me what formula I'm going to use to find the equation of the tangent line? Joseph? Yes, so y is equal to mx plus b. I know my slope, I just solved for that. The common point between the curve and the tangent line. I know all those three values. I'm basically just solving for b. So my y coordinate, 221. My slope, -240. My x coordinate was -4 plus b. So here you don't really have to, you can continue, you can multiply and show me, but b is equal to -739. And you can show me how to get that. I'm just confirming that your answer from hallway math is the same as my answer. So that means the equation, the final equation of the tangent line would be y is equal to -240x minus 739, which I know you're not used to such big slopes and y-intercepts, but when we talk about real world connections, the numbers either get very large or they get very small, especially with science-related problems. Okay. I did want to tackle a question, a different type of question than you're used to. And it looks like this. Right? So when you're given the slope and you're given an equation, let's go back to determine the points on the curve. Determine the points on the curve. Now we have done a question where there has been one point on the curve. But remember that sometimes a tangent line, if you're being given the slope of the tangent line, there could be multiple tangent lines with that slope. Different equations, but have the same slope. So then you're going to have multiple equations or multiple points on the curve that have a tangent line that is equal to that slope. So quickly, let's start off by calculating the derivative with the product rule. Notice that we are starting with y is equal to, so the derivative has to be written as dy over dx. dy over dx is equal to, that represents my derivative. Now, the original function has a derivative of 2x, the first function. My original second function is 2x plus 1, but that has a derivative of 2, double checking, 2, and I multiply that by the original. Now, normally I want you to show your distributive property, your collecting like terms, all of that. I'm just want to, for the sake of time, I'm just going to write the answer for now so that I can focus on the second half of the question. And that means my derivative formula, 6x squared plus 2x minus 4. Just for the sake of time, obviously I would expect more from you on a test. Okay, now we're going to tackle the second half of this question. There we go. That's as straight as I'm going to get it. The second half of the question tells me, okay, where is the derivative equal to -2? What are the x coordinates that make that happen? So I have to take my derivative formula, we're going to start off with saying, yes, 6x squared plus 2x minus 4. I'm going to take this slope information and I'm going to set the derivative equal to -2. Okay, my next step is I'm going to bring that over to make one equation. So I now have 6x squared plus 2x minus 4 plus 2 is equal to 0. Okay, that's writing out what I just said, which gives me the equation 6x squared plus 2x minus 2. Now remember, we're going to go back to grade 10 to figure out what are the points, the intersection points for this particular function. But before I do that, is there a way I can make that equation even simpler? How can I simplify further? Yes, Andy? Yes, I'm going to factor out the 2. So I don't even have to write it because I'm going to divide both sides by 2, basically. I'm dividing both sides by the greatest common factor. 0 divided by 2 is still 0. But actually, it doesn't hurt. Wait. Yes, that is. So I'm going to take the 2 out. Doesn't really change anything by taking the 2 out. but that does change my equation to 3x squared plus x minus 1. Does everyone agree with that? Okay, that looks right to me. Now, the 2 is irrelevant, but I do need to find the x points, the points of intersection. So, or on the curve that make the slope equal to that particular slope. So, what formula did you learn in grade 10? I can't factor this. I can't do FOIL with this equation. What other formula did you learn in grade 10, Juliana? Yes, the quadratic formula. When I tell you calculus brings up everything you've learned in the past, I was not joking. So we have to write down our quadratic formula, which would look like this: -1 plus minus the square root, change colors inside the square root, of 1 squared minus 4 times 3 times -1 all over 2 times 3, 2a. And that will give me x is equal to -1 plus minus. You have to always remember there is a plus minus here. Plus minus radical 13 all over a denominator of 6. I cannot ignore and just deal with the positive value. I have to remember that by solving this, this gives me 2 x values. X is equal to positive, or it's approximately equal to positive 0.43, and x is equal to approximately positive 0.77. I have 2 x values. Is that enough to answer the question? It's not enough to answer the question. I need to use those x values now to list the points of intersection. Right, that are on the curve, that have those particular tangent lines. So my first point, when x is equal to, and I don't need to write the x value. Let's try that again. My first point, when x is equal to 0.43, y is going to be equal to -3.38. I can get that right by plugging it into the original function. And when x is equal to 0.77, y is equal to 0.76. Those are my 2 points of intersection. The main portion of this that you haven't done before in any of my lessons is using the quadratic formula to solve. Okay, we still have a little bit of time, so I want to tackle one more difficult question, a question where there's more than one product. There's more than one product. So when I give you hallway math, it's filled with a ton of great practice questions. And I'm not just giving it to you and leaving it. I'm walking you through how to solve what I feel are the most important questions in the hallway math. So I'm pretty sure no one got to this point, but it is a fantastic question. -x squared times 4x minus 1 times x cubed plus 2x plus 3. How do we deal with 3 products? That's what we're going to tackle first. And what this requires, which you're going to have to do for the latter part of the course, is we're going to apply the product rule a few times. So we're going to first look at, in purple, the first function. And in blue, we're going to consider the x cubed function, the second function. Okay. So when I talk about the first function, I'm going to apply the quadratic rule in purple first. Now, this whole thing makes up y. I am only dealing with the fragment of y. So when I write the derivative, this is going to be part 1. When I write the derivative, I cannot write dy over dx because I'm not solving for all of y. I'm not finding the derivative of the entire y function. So what I am solving for is d over dx, a portion of the function that is just with the x variables and splitting the function up. And when I apply the product rule for d over dx, I'm going to get the derivative of the first, negative 2x, times 4x minus 1, plus the derivative of the second, positive 4, times negative x squared. Okay, and to simplify this a little bit, d over dx, I'm going to write the first function here of the first function is going to be equal to negative 12x squared plus 2x. Okay, so that is going to be my new first function. The blue function is going to be my second function. So now I'm going to use this information to calculate dy over dx. So dy over dx, notice I had to take the derivative. I couldn't just multiply x squared, negative x squared times 4x minus 1. I had to find d over dx in order for this to work properly. There's no simple answer to that. You would have to prove it using first principles to really understand why that is the case. Okay, so I'm going to now take the, let's see, what did I want to say? I want to take 12x squared plus 2x. I'm going to write that down first. So I'm going to write in purple, negative 12x squared plus 2x. And in blue, x cubed plus 2x plus 3. Remember, because this represents the derivative of the first function. So I'm taking the derivative of the first function times the second function. We can write that down. The derivative of the first function times the original, the OG second function, right? Second function. So that's the first part of the product rule. I'm going to move this down a little bit. Now I'm going to perform a sum. So I'm going to add this to the derivative of the second function. So I'm taking the derivative of the second function, which is 3x squared plus 2. And I'm going to multiply that by the original first function. The original first function was negative x squared times 4x minus 1. This was all the original first function. And you can see now I have a lot of expanding to do. So this is going to be a true test of your algebraic skills in terms of the expansion, your FOIL, how you distribute. So I'm going to walk you and list the steps step by step because this is for you to check your answers after. dy over dx. If I do FOIL with the first part, you should get negative 12x squared times x cubed, negative 12x5. I'm going to write everything down. Minus 24x cubed, and 24x cubed, yes. minus 36x squared plus 2x to the power of 4 plus 4x squared plus 6x. And I'm going to rewrite the second part of the question slightly. So I'm going to add multiply 3x squared plus 2 times, we're going to put that function together to have negative 4x cubed plus x squared. Okay, I still need to perform FOIL over here. That hasn't been done yet. But my arm is just hurting solving this question. That tends to happen with calculus. So dy over dx. I'm going to rearrange what I wrote in green according to degree. So the largest degree first, negative 12x5 plus 2x to the power of 4 minus 24x cubed minus 32x. So there is some grouping of like terms now, plus 6x. Did I miss something up there? Oh, wait, sorry, give me a second, please. 24x cubed, 32x plus 6x, and in blue, I have negative 12x to the power of 5 plus 3x to the power of 4 minus 8x cubed plus 2x squared. So I think this 32x is also from the expansion of here, but I'm trying to write like terms as much as possible. I probably should have written all of that in one color. When you collect all of your like terms together, it's going to give you negative 24x5 plus 5x to the power of 4 minus 32x cubed minus 30x squared plus 6x. Long equation, but as you go into real world connections like financial mathematics, where your graphs get more complex, your derivatives also get more complex. Just going to stop recording for a second, kids.